Hello again. We're back for lesson 70 in geometry. Okay, lesson 70 has to do with pyramids. So remember we have already talked a little bit about prisms. Well, now we're going to talk about pyramids. And so we need to start with definitions, which I know we've already done some of, but we're going to review anyway. Okay, so we have the vertex of a pyramid is that common vertex of all the lateral faces that come to the top. Then we have the base, which directly opposes the vertex. It would be the thing that the pyramid sits on. And then if I have a regular pyramid, that means that I have a regular polygon for a base. It also means that I have congruent lateral faces that meet up at the vertex. Then I have the slant height. The slant height is the distance from the vertex to the midpoint or edge of a base. It means it's not the perpendicular height. It means it's the actual side. So if I have a let's say I have well, I know that that's not exactly right, but you get the idea. So it's going to be, the slant height is going to be that right there. It's not going to be this height. It's going to be the height on the side. So from the vertex to the edge of the base, or a side of the base, or even a vertex in the base. Okay, then if I want to find the lateral area of a pyramid, that's going to be all of the rectangular faces, excluding the base. Surface area will include the base. So lateral area will just be the rectangle, or the lateral triangles, and then surface area is going to be the lateral area plus the base. So let's go ahead and look at this interesting little pentagonal pyramid that I made here. And we're going to figure out what the lateral area is and also what the surface area is, given that each edge is 4 centimeters and the slant height here is 9 centimeters. Okay. My equation to find out, and whoa, that does not erase very well, does it? Yeah. I'm going to have to use a different color marker. Okay. My lateral area is going to be given by 1/2 the perimeter of the base times the slant height. So because of that, in order to find the perimeter of this, I know that each edge is 4 centimeters. And I know also that I have a pentagon here, so I'm going to take 1/2. My perimeter is going to be 4 centimeters times 5 sides, and my slant height is 9 centimeters. Right? So if I multiply all that together, I end up with 4 times 5 is 9, well, I could just say, let's just do this, let's just go 2. 2 times 5 is 10 times 9, it gives me 90 centimeters. So 90 centimeters, actually squared, because we've got centimeters there, 90 centimeters squared is going to be my lateral area. Then I need, if I'm going to find my surface area is going to be that 90 centimeters squared plus the area of my base. So the area of my base, remember, let's see, let's draw my base here. Can you see that? Yes. Oh, that's pretty bad. Something like that. So each of these are 4 centimeters, right? And I need to figure out what is my area here. Well, remember, if I put my center point here, this is always going to be, I can make triangles out of my polygons. And since I know the base, I can go ahead and figure out then, if I am given the apothem, which I am going to give you, given that the apothem is equal to 2 centimeters, means that that's 2 centimeters there. So I can figure out what the area of each of those triangles are and then multiply it by the number of triangles that I have. So the area of a triangle is 1/2 the base times the height, so that's 4 times 2, which is my apothem, right? So 8 divided by 2 is 4, so the area of each of those triangles is 4. And since I have 5 triangles, I have 4 times 5 is equal to 20 centimeters squared. So 20 centimeters squared is equal to the area of my base, and so my surface area is going to be 110 centimeters squared. Okay, so let's go ahead and do the same thing using a hexagon this time. Wow, that That red marker was a doozy. Okay. So let's go ahead and say I have a base that looks like that. So I have a pyramid that has that. I'm gonna kind of flatten it, right? So here's my pyramid. Okay, I think I missed a line there. There's my pyramid, and I'd like to find out what is the lateral area and the surface area of this pyramid, given that my slant height is 8 centimeters and the front edge of my base here is 3 centimeters. So again, for my lateral area, I need the perimeter times the slant height times 1/2, right? We'll put the 1/2 in there. All right, so now I have 1/2. My perimeter is going to be 3 times 6 because I've got 6 sides, so 3 times 6, and then my slant height is 8 centimeters. Can't forget my centimeters. So that gives me, let's see, 3 times 6. I don't know, what is all that? It is 72 centimeters squared. Okay, so that's going to be my lateral area. So that's just all of those triangles there that's around the base. Now if I want my surface area, I'm going to take that 72 centimeters and I'm going to add to it the area of the base. Now in this case we're not given the apothem, but fortunately we can figure it out because this is a hexagon, and I know that, remember how we did that thing where we end up with a 30, 60, 90 degree triangle? I know that in each of this is 60 degrees in the middle here. And so if I pull that out, do I have room to pull that out? If I pull that out and I cut that in half, I end up with a 30 and a 60 and a 90. And I know that my base is 3, which means that this is 1.5. And then I can go ahead and calculate, because this is a right triangle, what that is using my reference triangle. So remember, my reference triangle would be 1.5 times the square root of 3, right? Would be my height. So now I have to go ahead and figure out what my area of that triangle is. So that would be 1/2 the base, so that's going to be the base of the whole triangle, which is 3, times 1.5 times the square root of 3. Okay, well that makes things really interesting, doesn't it? So what I end up with is 1/2, so that's 1/2 times 1/2. I end up with, let's see, what did I do there? Okay, I can end up doing this in a decimal form. It might be easier. I don't have to, because what I could do is make this, let's go back to this. If I have my 1.5 times the square root of 3, I could use that as a fraction and say that it's actually 3/2 times the square root of 3. So what I end up with is 3 times the square root of 3 over 2, right? So I can, instead of this, I can make this 3 times the square root of 3 over 2, right? And then I can get 9 times the square root of 3 over 4. So I don't know where I can write that. 9 times the square root of 3 over 4, because I have my 1/2 in there. And that would be my my area of my triangle. Then I have to multiply that times 6, because I have 6 triangles, and that would be the area of my base. So if I do this, I've got 2 and 3, so I end up with 27 times the square root of 3 is the area of my base, plus 72 centimeters squared for my surface area. I know that was a little bit complicated, but the point is that we can figure out what the surface area and what the lateral area is depending on what information we're given, and also because knowing the base and knowing the formulas that we have to calculate our lateral area and our surface area as well. Okay, the last thing that we have to cover is, in a pyramid, trying to figure out what is the volume of a pyramid. And if we think about a prism, so let's say that we have a prism. Go back to our pentagonal. Let's say that we have a prism, and this is going to be bad, I can just tell. want to connect here. I guess those would connect, wouldn't they? That would connect, and that would connect, and that would connect. Okay, so if I have a prism and I'm going to carve away everything that I need to actually make it into a pyramid, so I'm going to carve all that away and I'm going to be left with a pyramid, what I'm going to actually end up with is carving away 2/3 of my prism to get to my pyramid. So if I know how to calculate the volume of a prism, I just take 1/3 of that, and that will leave me with the volume of a pyramid. So if you remember that if you carve away 2/3, you end up with 1/3 the volume of a prism. So the formula is going to be 1/3 the base times the height. Now when I talk about height, I'm not talking about slant height. I'm talking about altitude, which is always going to be the perpendicular height from the base to the vertex. Okay, so that's important in that case. So let's say that I have a square base, and I've got this pyramid here. Use your imagination there. And so I've got a square for a base. Each side is 5 inches. And I'd like to know what the volume is. Well, this tells me that I need 1/3 the area of the base times the height of the whole thing. And the perpendicular height, I'm going to say right into the middle there, perpendicular height is 12 inches, not the slant height. So my base, this is a little bit easier because it's a square, the area of my base is going to be 5 times 4 sides there, which is 20. So that's 20 square inches times the height, which is 12 inches. So I need 1/3. See, 1/3 of 12 is 4 times 20 would be 80 cubic inches, I think. 1/3 of 12 is 4 times 20. Yes, 80 cubic inches. Okay, so that's going to be how you're going to go ahead and do the volume for all of your pyramids. Just remember that it's 1/3 the area of a prism of the same shape. Okay, so for this lesson, I'd like you to just do the odd problems, and then if you could please add number 2, that will take care of all of the different scenarios in lesson 70. And then we'll go ahead and pick up with investigation 7 on Monday. So I will see you then, and hope you have a good weekend. Bye-bye. Well, I realized that that base was supposed to be 25 because it's 5 times 5, not 5 times 4. So that's where I made my error. So I stuck this in the middle, so it's probably going to sound funny, but there you go.